Hey, Zoom Zoom, thanks for joining. We're going to get started here in just a moment. How's the audio levels? All right, let's get started. So, for those of you familiar with ServiceNow, we're going to be talking about ServiceNow's service mapping feature. For those of you not familiar with ServiceNow, service mapping is a way that we can discover some of the we can discover our infrastructure in a corporate environment, find that infrastructure, and then understand how all the components are tied together, what their dependencies are on different things. So like if I have a web application, right, that web application's got to run on a server. That server might be virtualized and it may have a physical host underneath it. So we kind of try to want to show that as well. And then, so that way we know that if there's a problem with the underlying virtual host or infrastructure, that is going to affect either a database or a web server, that will affect kind of what we think of it as a business application. So we're enumerating that inside of ServiceNow here. What I've been doing for a couple of these streams is putting together some lesser known service maps for things that probably you wouldn't find in a corporate environment. One of which is a PiHole. PiHole is one of the things that essentially does DNS blocking for the entire network. So it's basically a DNS server that has blocking in it, so that known ad sites and things like that don't actually ever get loaded. But I figured, hey, this is a somewhat complex enough application sitting on top of my NAS file server that's virtualized. I figured probably be a good good thing to kind of show all the different components of ServiceNow, how you set them up, and some of the additional coding that we've got to do too. So let's get right into it. So if we go into service mapping here in our application, in our ServiceNow application, we can kind of come to home and see the different service mapping potential options to approve. But if we go into the application services here, we can see we've got two applications that I've previously created on a past stream. One of them is the PiHole admin portal. So kind of click into here and kind of see how it's been configured. So there's some business criticality information here, like whether it's a critical service or not. We really haven't touched that or played with that too much. But the meat and potatoes of it is we provide it with a URL endpoint for this. I'm just providing it the IP address, the protocol being HTTP, and its endpoint of admin. And then it actually generates a map. So ServiceNow will take that and actually query that server, log into that server using some discovery credentials. Those discovery credentials... Hey, Angkor, how's it going? Welcome. And so it'll take that discovery and it'll create this. And so one of the things we had to do is you'll see the entry point comes into a light HTTPD server, and that actually connects over to the actual PiHole FTL server, which is actually doing all of the DNS lookups as well as the blocking. But this is sort of the admin console that allows you to get in and kind of take a look and see what's all going on in there. A couple of things that we had to do to set this up. So first and foremost, we needed to make some discovery credentials. So in the discovery module on the left here, you'll see there are some discovery schedules. So we had to create some discovery schedules first and foremost, and we also had to create some credentials. So in the credentials list, there's some of these here that are, kind of created from just some just some out of the box, demo credentials. But these are our credentials. So it's Linux Disco Cred with a username of SNDisco and a password. And I've got a NAS drive. Funny Zoom. And this is this Linux Disco Cred. Essentially, I set up on on one of the virtualized instances on my TrueNAS server. I set up a CentOS system that has a mid server on it. And mid server allows you to connect from ServiceNow, which is in the cloud, down to your on-prem instances, so that you can have some way to connect and start to, discover inside of the network. So this credential is created, and we put this credential on all the things that we wanted to discover. So this credential exists on my TrueNAS server, and it exists on some of the hosts, the virtual hosts that it's virtualizing as well. And then if we kind of look at we created a discovery schedule that's sort of on demand, and it's just got two IPs in it while it loads here. The first is essentially this is our PiHole server. This is our mid server, and I think I did a quick discovery on the underlying hardware server for it. If we go over to mid servers, we can kind of see what that looks like too. So the mid servers is basically just a client that's running on a Linux box that I've got. I call it the Disco One. Put it on the mid server one host name, and you can see that it's running on this Linux host OS. This is its IP address. And this is basically what's executing all of our discovery commands, SSH commands. We'll go into that in just a moment. We'll show you the patterns and things that we had to create for Linux discovery, as well as discovery of this particular, application. So are they like donut holes? They're kind of like donut holes. You only get the good stuff, right? You only get the middle. Whereas, you don't get the rest of the donut, which just makes you fat. Donut holes are surprisingly make you thin. So with this, we've got no, you can be as shenanigans as you want. We've got 3 total viewers, so it's great because it kind of delays it a little bit, so that if people who showed up a little bit late, they'll still get some of the explanations. But yeah, I mean, if you've got fun antics, bring them on. So there's so when we first did the discovery of this server, all the server information is stored in the configuration management database, and in the CMDB, there's a section for servers, and so we can just kind of open up all these Linux servers and see the 2 Linux servers that we've discovered already. So the first thing we discovered was our PiHole server. So we'll kind of just jump into that. And in ServiceNow, it keeps track of everything that is important to either the hardware or the software that comes along with it. So you can see this is a free BSD Beehive Linux server. It's got a serial number. The serial number is virtualized serial number. It doesn't mean anything, but it is unique for that particular VM. It's just how much RAM is allocated to that. The CPU manufacturer is the underlying thing, and then operating systems, OS versions, speed, etc., IP addresses, and then down here is, I think, some of the most important cool stuff. Donut holes make great insulation for your walls. We're not talking about food anymore, or if we are, oh my goodness. I would not want that insulating my walls. And so you can see here, there's it pulls all the software from the Linux system, pulls all the running processes. And as you can see, we've got light HTTPD running as a process, and you've got PiHole FTL running as a process. And here is, I think, some of the most powerful stuff about ServiceNow. So now you can see that we've created these relationships as well. It's running PiHole FTL. It's running a web server. And then you can also see that there are some application services being mapped on it, right? So there's the PiHole admin portal and PiHole FTL, and that these 2 things are connected. So if we pull up in the actual dependency view, it's a cool, nifty little graph. Kind of shows you how everything's all interrelated. So this is our Linux server, right? And it's got some disks attached to it. So if any of these disks, essentially, or network adapters fail, it's going to negatively impact the Linux server. And if we look higher up, anything that happens to the Linux server is going to negatively impact anything above it. Likewise, if the PiHole FTL goes down, then your admin console is not going to do anything. But if, let's say, your admin console goes down, your DNS blocking is still going to work. And then it shows you kind of what these things are for, right? Like what these applications are all mapped to. And this can help with, larger contexts of incident management, problem management, change management, things that are used to, that a large enterprise organization, hopefully even small organizations, use to, make sure they're providing the best service they can, with their IT resources. It's been a delicious learning curve. I don't have a response to that. Delicious learning curves are delicious. Delicious curves. There's a joke in there. I'm not getting what it is. There's another joke. Something about delicious curves. Something about my wife. I'm sure there's something in there. So let's take a look at some of the patterns that we had to create. So one of the first things we did before we get into the patterns is there's a classification process in Discovery. So as part of Discovery, we have to classify our processes. And this light HTTP server was initially showing up as Apache. And that was because of some incorrectly configured out-of-the-box patterns that were looking for anything that contained the letters HTTPD. Well, light HTTPD contains HTTPD as well, but none of the configuration files are the same. Completely different type of implementation than an Apache server. So we had to adjust some of the classifications. So we've got this light HTTP server that we created first, And then we also have this Apache server that we had to modify. So with this server class, with this process classification, you say if the name of that process is light HTTPD, then it's classified as a light HTTPD server. For Apache, name must be exactly HTTPD. If it's not, then it's not gonna work, right? And then it kicks off some patterns and whatnot. And actually, I've left something out. It's not necessary to have this trigger probe that's only with horizontal discovery that's just going out and searching and scanning for IP addresses. Top-down discovery, what we've done, dependency mapping, where you give it like an endpoint. That doesn't necessarily use this trigger. So let's just add some triggers first. We're just going to add the one. And let's see, we're going to do a horizontal pattern. We're going to add that condition script from Apache. And instead of doing Apache pattern, we're going to do the light HTTPD Unix-based OS. So we'll save that. Now, at least if we run horizontal discovery, it'll find any additional light HTTPD servers that may be, bantering about on the network. Turns out AWS EC2 discovery requires a mid server in AWS. Interesting. It's definitely easier that way. The alternative, you don't necessarily need that if it's on a network that's already been approved. So if you've got like a larger wide area network that includes the data center in which your mid server's in, then you don't have to, and you've set up the network that way to be inclusive of that, third party network. And there's a trust between those two, you should be able to do that. That goes beyond my pay grade. I don't know how to set that up. I usually ask the AWS people, can my thing access AWS? So yeah, if you're in a network that you've created in AWS, you're probably going to need to spin up an EC2 instance inside that network and put a mid server on it for sure. So welcome. All right, let's keep going. So we've got this classifier for light HTTPD server, and now we're going to kind of just dive into this pattern and see what this pattern looks like. And I'll probably also take it and compare it to the Apache Unix-based OS, because that's what I copied it from. And I took a lot of the stuff out that wasn't really relevant. Oh, yeah, no, that's yes. And that's like networking like 509. Like that's some advanced networking concept if for routing. I'm not even sure how you would get around that. I think maybe just don't do that is the only way around it. So that's an interesting problem. I would not want to be on your side of that, having to deal with that. So actually, I made a change in the Apache one as well. So for the Apache one, I also made it that we must enforce process classification. This goes back to that classifier we just created, and it has to match. If it doesn't match, it will not run this. This was also unchecked. So there was no checks for it that were sufficient because it said contains HTTPD instead of is HTTPD. And then for the lightweight identification, I put in an extra section here that says, is it light HTTPD? So it shouldn't contain this. If it does contain it, it'll terminate it as not expected, and it won't continue to run this pattern, and it'll keep going down for the other pattern, which will eventually make its way to light HTTPD. So first we check to make sure that, I didn't rename this. This is check process name to match Apache. It should be check process name to match light HTTPD. Let's fix this right now, actually. All right. It's It's cosmetic, but it's confusing if it's not fixed. So this essentially checks the process to see if it's matching light HTTPD. And if it does, then it continues. If it doesn't, it exits with not expected. We grab the home directory, and actually let's debug this. Let's debug the whole thing. We'll see it working in real time. And just let me know, guys, if you can see the text okay. I've kind of messed with this since the last stream. I kind of blew up the text a little bit, kind of zoomed in a little bit more, and hopefully that's a little bit easier to see. There's also a PowerShell screen in the bottom right. Kind of change those texts as well. Not doing anything with PowerShell quite yet, but if I need to like jump into any of the servers to kind of look through or dig through config files or test out various discovery things in real time, shell commands, I'll probably use that. But for right now, I'm just going to leave it there in the corner. If it blocks anything, I'll move it out of the way. Yeah, just let me know how the text looks. So process for this, essentially, we're getting the home directory, right, and the installation directory if one exists, because sometimes you may have a directory with a lowercase d that with a keyword lowercase d that actually specifies a different directory than the default. This doesn't. So in the second section, in the next part, and actually I'm going to just go all the way to the bottom, so it doesn't have to rerun this debug process. It'll run through all the steps, and then I can easily just kind of click through each one without having to have that loading screen. So in this case, we get the config file from the F keyword, and we save that in a file. We save that in a config file variable. And then if the install directory was empty, which is that home directory, so if that's still empty, then we'll grab it from the config file. So we can grab that old config file that we had and just take away the light HTTPD config and grab etc light HTTPD. So we know where it exists now, and so we can save that off as well. And then we're going to check to see if the server config file is relative or not. Essentially, if there's relative paths. In our case, we don't have that, but I left that in just in case somebody has a relative path. And then we'll get the version from running the -v version command. And so, like when we do this, we run this command, the output we get is going to be this huge, very large file, right? You can see there's a number of pieces of information here. We don't care about any of that for getting the version. We just care about this first line. So we're going to just include that line. And we know that we've got a delimiter of a /, and we're going to take the second position of that /, and that's how that version gets populated in there, because this style and type of text is always going to be the same for all these config files. So after we do that, because I clicked into it, it's going to try to debug again. Let's go all the way to the end. So setting the display name, display label with the host name, again, if the name ends with @ so the first one is just light HTTP server @ and then if there's a port table, there isn't one, so we're going to do name ends with @ and actually I probably can get rid of this. Yeah, because we actually don't have any port tables, because I removed that. So we'll do that after I kind of walk through the rest of it. Again, taking a second look at things always makes you figure out, oh, I did that wrong. Getting this short description, again, that's that first line that we saw before this, except we're taking the whole line. We'll clean it up, and then we're going to set the type to light HTTPD, and that creates our process, right? That's actually what this whole pattern is, what creates. Let's get out of the dependency view. Yeah, so sorry. That whole pattern is what creates this entry here, this light HTTP server, and relates it to the configuration file. So again, ServiceNow out of the box doesn't have a light HTTPD connection, but or a pattern. However, it does have something similar as Apache, and it's easy to just kind of copy and reuse some of the patterns. All right, cheers, Anchor. Thanks for stopping by. All right, so let's clean this up. Let's do this. Instead of ends with at, let's just get rid of all these criteria, preconditions. We don't need those preconditions. And we don't need this set display label first one. We can just set the display label the correct way for the first time. And then I think everything else is good. We'll save and publish that. All right, and now let's take a look at the Apache. What's in Apache? It's quite large. It's much larger, right? There's a lot more double, triple checking for stuff because it could be put in a lot of different locations. So if the process executable contains HTTPD Apache or HTTPD SD, getting the home directory is very similar, right? But then there's a whole bunch of other things like getting all the port information from Apache, which is different in Light HTTPD, and getting config files from various things, extracting the directory from the version command as well. There's also some stuff in here for IBM servers as well. So IBM variants of Apache. I took all that out because that doesn't apply to Light HTTPD, and short descriptions, etc. So we did that in the last stream as well. This time I promise I'm going to save the VOD to YouTube so I can kind of refer to them later. But yeah, we've got so we'll close this down. We've also got in this process classification, and you can show a discovery log of any process classifier, right? So as part of this, you can see here's Light HTTPD. It identified it correctly. And then you'll see here there's a PiHole FTL attached to that. So what we do then, let's open that back up again. I closed the window. So in the Light HTTPD endpoint, we've got this thing in connection section now. So what connection section does is that for service mapping or top-down discovery, once it finds that this is a Light HTTPD server, it will follow the instructions of all of the connection servers to see if there is a configuration-based connection it can make. So in other words, it runs that code to see if there's another relationship downstream that connects to something else. And so let's dive into this, kind of talk about what we had to do for this. This is a relatively short one. The first thing we do is we try to pull from the config file that we found in the previous pattern, take that config file and see if there is a line in the config file that includes a PiHole-admin config. If it doesn't include it, we're going to exit, right? So if this config file exists and we know what it is, then we'll continue on. If it doesn't exist, then we have a Light HTTPD implementation that isn't running on top of PiHole, so we don't care, right? And so we want to move on to the next thing. So now the next thing we're going to do is take that PiHole configuration file and find the server document root. So let's just jump into debug mode here real quick, do it again, and kind of show you what some of this output looks like. All right. So in this case, we're going to retrieve this file content from the PiHole config. And you can see I've just filtered it down to server document root, but you can see here, this is the actual configuration for all of the firewall rules, as well as all of the redirect rules for the PiHole. But we care about is just the server document root, right? And so the server document root sends us to this file system structure inside of our Linux box. So, because now that we know what this is, let's discard this. Oh, it's going to actually kick us out. That's fine. We won't do that. So then we're going to set the admin folder by taking that document root and appending admin to it. And then after that, there's a set of 3 different properties in here in this particular thing. So we found the document root and then added admin scripts PiHole php ftl.php. And we found this information here, which describes where the PiHole FTL configuration file is, the IP address that this admin application is connecting to, and the default port. So that's incredibly important for the next step where we actually create the connection. And creating the connection is what is going to bring our 2 service map applications together. So you can see here in the application flow, I've got a TCP endpoint, and I'm putting in the host, which is that second value. If I open this host up over here in our variables, you can see it pops up. I've got a default. I've got, these things are always in this order because it's in the order in which it was captured from the file. I have the default FTL config file. I've got the default FTL IP and default FTL port with its name and value pair. And so then I'm just taking that second entry and that third entry, and I'm getting the values for each, and I'm applying them to the host. Now, one of the things I don't think I actually need, it's just something else it's extraneous that I don't need. So we'll save this, publish it. And that's actually what gets us to here, right? And it creates this. But you'll notice that this is a connected application service, right? So this connected application service was because when I did find PiHole FTL, I simply right-clicked the service and I said create a brand new service. So I actually have a second service because I do want to consider these different services. One is, they're dependent upon each other, but they're like a microservice. There's this service here has a completely different function than the admin console, right? Theoretically, if as you're designing or doing something with service mapping, you may consider this to be all one application, and that's fine as well. But I consider them to be different. This is a critical part. The admin console is like non-critical. That's why I said I don't really care. If the admin console has an issue or a problem, I don't want everybody to freak out because PiHole's still running. Just the admin console is having some difficulty. But again, then it finds this particular object, this PiHole FTL. A couple of things I had to do too, like I made this into a generic application for now. I didn't create its own table, but for the admin portal, right, for the light HTTPD, I actually did create a brand new class. Let's go check that out here real quick in the CI class manager. So this is our CI class manager. For those of you familiar with it, if not familiar with it, it's basically how ServiceNow has you manage all the table structures and ancillary things around discovery and CMDB. You manage it all from the CI class manager. I think previously, maybe 8 years ago or more, there was no CI class manager. It was just, you just had to know the table structure. You had to manage it like any other table. But there was a lot of unique things that came along with CI classes that were not true for other tables like task or even user or property tables. So if we look up light HTTPD, we can see in the list of configuration items, I've put it under the web server. If we just look at all web servers in the hierarchy, you can see that the web server's got Apache, Cloud, iPlanet, Microsoft IIS, Nginx, and so we just added light HTTPD server as an extension. We gave it an icon. Really didn't do much here. All these identifier entries are exactly the same as its parent. No additional dependent relationships. We don't have any reconciliation rules because we're just using ServiceNow discovery and service mapping. Reconciliation rules, super helpful if you've got an environment in which has multiple data sources. You can to say who wins and who loses for each down to each field level. So again, also CI health. We didn't really do anything here with that because, again, this is just a development instance. We're not actually managing and monitoring health, at least not yet. Maybe we'll do that in the future, where we install ITOM operator and start doing event management against these things, make bad things happen, and then maybe automatically fix them. But we got to worry about getting our infrastructure discovered first before we can start talking about that. So that's kind of where we left off previously. And so for this stream, we're going to kind of maybe do a little bit of cleanup on the PiHole discovery itself. But one of the major things I want to kind of get to is looking at the Linux servers, right? So I created a new thought I created BSD Unix servers. All right, so there's a couple of Unix servers. I created a new Unix server and a Unix discovery for BSD. Where is it? It is not here. That's wild. All right, give me a second. I'm gonna go find out what I did with it. We'll go to discovery. We're gonna check out this. Let's see, status. Where's our status? We're below discovery schedules. Okay, so I did create a BSD server. Oh, it put it in a BSD server, but then it put it in the Linux server class. So we probably have some things we got to clean up here too. Where is it right now? Oh, it's in the Linux server class. Okay. Yeah, we're gonna have to probably clean that up because there's a BSD class. But you can see here there's this freenas.local, this is a physical server. This is a real serial number. It's manufactured by Supermicro. That's the main board in it. We don't have RAM, we don't have CPU counts, again, because we've got a lot of errors in what we're running. You can see here we've got not a number as a net mask for some of the network adapters. So a lot of these things aren't working. I just kind of put the Linux pattern against it, and it has found some additional stuff, but not all the right stuff. So let's work on getting this to be up to snuff. And then once we get this running, you can see it's found KVM, right? So we also need to find Beehive, and we need to find the virtualization layer. I think it's incorrectly calling it KVM because I think it's actually Beehive, but we'll find out as we kind of drive through that. We'll find the virtualization layer and get it to connect this physical server to its virtual counterparts, both the mid server and our PiHole server. So let's get started on this. Questions in the chat, feel free to hit me up anytime, or with funny stuff, down for that too. So let's go back to the classifiers, right? Because we've got Unix classifiers, we've got a FreeBSD classifier. FreeBSD classifier is putting it in a table of a BSD server, and it's triggering some of these probes, and it's triggering Linux installed software, and it's triggering the horizontal pattern for a Linux server. So let's open this Linux server pattern up in a new window. Let's close out some of these other windows so we don't get confused. We're also going to open up Pattern Designer again, and so we can create a new pattern. We're also going to go to I believe it's SA pattern, SN pattern. I think SN. That right? Nope, not right. It's SN. The actual metadata for the patterns is stored in, I don't remember. Let's find out. Let's look it up together. Not remote tables. Let's look something else up. All right. Oh, it's not SN, it's SA. I would have never found it that way. Thank you, Internet. Okay, and we're going to find the Linux pattern, which is Linux server. We'll drill into this. And this actually gives us the metadata. So now we can say free BSD server instead. Right click, insert, and stay. Then we're going to open it in a new designer, and we are going to edit some of this pattern stuff. So we got to change, when we copy something like this, we got to change the pattern ID to be the current ID of the thing. And we also have to change the CI type. I believe it's BSD server. Let's triple check on that. Ah, it's got the U in front of it because we created it. How sad. And then let's see here. And each step, which we'll manage the steps actually inside the pattern. So we'll save this pattern, and then we will publish it. That will make the pattern values change. Check the ID, they're matching, CI types matching, fantastic. So now we can like drill into this discovery section here. CI type is wrong still. Let's change this to BSD server, save it, publish it. Of course, that's the wrong one. What happened to it? I've gone and messed up. We're gonna just do track files, save and publish that. Let's not do that again. All right, so this is all looking correct, right? Yeah, fantastic. That's what we wanted. We're looking at this here, and I got confused. Okay, so with this, we're going to try to figure out each step of the way and what works and what doesn't. Because we know for a fact some of these commands aren't working appropriately. So we're going to step through each one and then fix them. So in this case, our host is 1024.115. That's our FreeNAS box. So we'll just connect to that. Pre-execution? No. Okay. So get the system info. So uname A, that should return something, right? That should return all the information that we need. Actually, since we're doing this whole section, let's go down all the way to format host name. I think all of this is working correctly because the name came back correct. So the system name, that's the uname, right? And then extracting it from OS, the OS name is coming back as FreeBSD. Fantastic. We like that. The OS host name is coming back as freenas.local. Pro tip, when you're working with service mapping and pattern designers, when you're on a particular step, it'll only show you the variables from the previous steps, not the one you're currently on. You can click test to actually get the output from this step, or if you're reasonably certain that it works, you can just go to the next step, look for the variable for the previous step. So you'll see me, if I want to find out if the extracting this host name is correct, I'll go to the next step and look for OS host name. It's freenas.local. That's fantastic. If the OS type does not equal AIX, well, that's true, right? There should be an OS version that pops up in here. And we got OS version of 13.1 release P7. I like it. And then the OS host name is going to turn into a formatted host name. And then we have to decide whether or not to use the new name or the old one for formatting. So if the old OS host name is empty, or this script returns false, so is SSH trusted? So there's a property. Let's jump over to that property real quick. So there's a property in Discovery where you can set what wins and loses on host names. And actually, I don't know if I've set this yet, but here you can see there's like SNMP is a trusted host name source. I actually don't agree with that most of the time. SNMP is usually a fully qualified domain name, and people don't like that as a host name. So we usually say no to that. SSH is a trusted host name source. Yes. Fantastic. It's already set. So that's great. There's some other properties here, but this is what it's talking about. So if this property is no, then that step won't get run. Let's just say this here real quick. I don't have any SNMP devices yet, but maybe I will in the future and I'll forget that. So this is true. Let's see here. So, and is SSH trusted is false. So that would return true. So this whole thing was false. Yeah, that's some crazy logic. So you're checking this to see if it's false. And if this is false, then this false equals false is true. So the condition's true. Oh my goodness. But that's only if OS hostname is empty, and it's not. OS hostname has something. And then we'll just take a look at the formatted hostname. So good. Hostnames, that looks perfect. We don't have to do anything there for the debug process. So now we're going to transform this tail of OS version, name to formatted name. That's fine as well. Now we have this Linux identify, and I think this is the part where it's probably going to fail. So we'll just go all the way down to the rel Linux serial number and see if this brings us what we want. Here we're just setting a privilege command. Let's make sure this is correct. Get DMI decode. So let's just see if this runs. We should be able to fill out all these variables: manufacturer, model number, serial number, UUID, serial number, and model ID. I believe those are all coming through okay. Last we checked, as we saw, yeah, no UUID. So we got the serial number, and we've got the product name as well. That's interesting. There's a space in front of them. Is there a space in the actual server? Let's find out. Or does it may clean it up itself later on? I just haven't gotten there yet. Yeah, no, there's no space there, so that's good. Failover, get DMI type 1. So if DMI type 1 is empty, well, it's not empty, so that's cool. Convert the output to JSON. I don't have any issues with that. Parse DMI type 1. DMI type 1 is not empty. Yep, that's all if none of that happens. So DMI type 2, let's see if this comes back with a baseboard serial number. Again, I think it will, because we have that in there. So I think there's nothing probably wrong with this. Yep, there it is. We don't care about any of the failovers. All right, let's try type 3. The type 3. So they update the serial number, update the UUID, baseboard, chassis, combining them. So you're removing any non-serials, duplicate serials. This might be a problem. All right, let's do this. Let's copy the entirety of the Linux identify. So I don't want to edit this. We're going to call this FreeBSD identity. We're going to grab Linux hardware. And we're going to get Linux, I believe it's network, but let's check identity again. Yeah, Linux network. Oh my. Okay. We're going to call FreeBSD network. Okay. So now if we go into Now we go back into here, and I believe if we I didn't want to do that. We're going to trash that. So we're just going to discard the whole thing. Say, oops, we don't want to do that. And we're going to come in here. We're going to say Linux identify. We're going to right click, cancel that operation. We're going to right click. We're going to remove Linux identify identity. And now we're going to right click, new step. We're going to do FreeBSD identity. We're going to grab a library reference, FreeBSD identity. Now, FreeBSD identity is going to have the Linux stuff inside of it still. So now we can remove Linux. Actually, I don't need to remove it. I can just change it, right? Because I'm already in the FreeBSD identity. Oh no, that looks terrible. FreeBSD hardware information and FreeBSD network. Okay. So we needed to change something. We need to change this. Let's see. File table. Let's do this. Let's find anything that contains CMDB CI Linux server. So this one here contains this, and we're going to change this to EU CMDB CI BSD server. And then we're going to come down here and go to, again, same thing, EU CMDB CI BSD server. Again, we're changing all the server references because we copied from the Linux server. All right, there we go. Save that off. All right, cleared all that out. We're going to go back to debugging again. All right. So now we've got that going, we can go to this FreeBSD identify, and we'll go all the way down to this reference relationship to Linux serial number, and then we'll get started on Linux on the network part of it. Let's see, we need to rename this to FreeBSD. We don't confuse anybody. All right. And then rename this guy here to FreeBSD also. It's this stuff that I think is failing. So let's run through this whole library and figure out which parts need to be edited and changed. This may require us to look up some man pages for FreeBSD. Oh, see, we're already getting errors showing up in the debug section. All right, I found some errors. Please view them below. Well, hopefully we can. Okay, we've got some good stuff. So let's take a look and start driving through all these. Kernel 13. Okay, great. Get the interfaces. So ifconfig. Does ifconfig even work? I came back with nothing. So that's where we're going to probably need to grab our trusty PowerShell and start figuring stuff out. This is the exciting infrastructure part of service mapping, is that you need to kind of have an idea about infrastructure or buddy up with a friend that knows something about infrastructure in order to kind of create these patterns, because you can't create these patterns just with, web coding knowledge alone. So let's SSH into this server here. Fantastic. Does ifconfig even work? ifconfig absolutely works. Awk exists as well. If we take the whole line, maybe printf doesn't work. Messed something up there. Oh, I forgot to close. All right, says, let's see, syntax error at source line 1, context is line equals 0. Okay, so I don't think it likes the printf statement. Space in the printf line. All right, let's go look at some other patterns. Other Unix patterns. Maybe we should have looked at Unix instead. Or HPUX. Ah, that works much better. Let's do this. Let's instead let's remove this. Let's do HPUX network. We probably still need to make some adjustments, but I suspect that HPUX is probably closer than a Linux variant because HPUX is still Unix and so is BSD. Let's go to the end here. Okay, there's that. Parse interfaces for easy access for extraction of IPs. Get IP addresses. Oh, nice. IPs and net masks are coming through. After sheets, that's coming through. Get Mac. So this didn't work before. LAN scan IA. Okay, what if we just try LAN scan? All right, so LAN scan doesn't exist in FreeBSD. So FreeBSD equivalent to LAN scan. Oh no, we don't want to do that. Find FreeBSD MAC address. ifconfig-a works. All right, what else are we doing here? Set up IP addresses. Let's just putting it in max. So besides max, let's see if everything else works. So IP addresses.ip. Oh no, I've got this terrible thing up here. Can't get rid of it. This modal or this pop-up sucks. All right, IP addresses. We've got IP addresses. I don't know about, okay, we've got IPs. We don't have max. We're not using max. Remove duplicate IPs. That's fine. Merge adapters with max. Okay, so let's go back to our patterns. Let's go find the Unix, or the HPUX network. Let's clone this one also. We'll call this FreeBSD network. Oh, we already created a FreeBSD network. We got to delete the FreeBSD network because we don't want that. Grab that sysid, copy it in here. It's referencing itself correctly. And now we can go here and find the FreeBSD network. All right, let's do this. Let's save all this with the libraries, publish it. New step below. Turn off debug mode. Oh, that's exciting. We got Control-Shift-R, leave the page. There we go. That's much better. All right, rename FreeBSD network. Stretch this out a little bit. Get the interfaces. Can I please get max? So we know that LAN scan IA is not going to work, but let's see if we can do man ifconfig. Wait, can we do a grep maybe? ifconfig-a. Let's just pull it all in and do the parsing inside of ServiceNow instead. Hmm. See if there's a quick way we can find and not have to do the parsing service now either. So ifconfig output just MAC address and interface name. Stack Overflow is our hero. The solution looks good. So ifconfig pipe to grep. Anything containing a letter or number plus any number of numbers plus. All right. Oh yeah, sorry. One or more plus. Followed by a semicolon, followed by ether, followed by anything. Followed by anything. anything. At least one of something. And then grep that. Okay, pass that into grep also. Find ether anything. All right, let's give it a shot. Why not? Looks safe. That's exactly what I want. Let's go back to FreeBSD here. We'll, instead of ifconfig-a, let's throw in this. We're going to have problems with the quotes, aren't we? Let's escape those. On that command, see what happens. Excellent. If the delimiter is space, get rid of this delimiter. That's the delimiter is colon. And the delimiter is space. Oh, no, I can't do colon. I have to do just space delimiter. Gross. Can't do colon because colon is part of the MAC address. Zero work as a position? Zero is not a position. Can I put a second space as a delimiter? No, that doesn't work. Can I put the word ether as a delimiter? I can. Let's do this. Let's try to use. Yeah, I hate this. Let's. Oh, we gotta go back to space. Yeah, you are absolutely correct. If I was writing this from scratch, probably, because I'm just trying to fit it into what's already there to do as little work as possible. This works also. So you're absolutely correct. ifconfig has all of that information. And in that case, like I don't even need to worry about this whole thing, right? I could just do ifconfig a, and I believe it's like in a pretty good format already. We could basically just do like a value, like name value pairs and stuff, but I'm trying to do it somewhat sanely. I feel like this might have something to do with my problem. Let's can that and see what happens if I just do this. Does it give me a different formatting? Oh, that's interesting. My problem is I don't understand the grep commands that are being used, but grep v. Let's go back to that thing again and see if there's anything else that they came up with. I like that best. It's the best solution. Okay, well. Well, let's hope Pearl's on here. I wouldn't recommend doing this for any other sort of a implementation because you can't guarantee that Pearl's going to be there. And Perl might not even be in my instance. But it is. Description ether. I got VNet 0, VNet 2. Bridge. Okay. Well, in any case. This kind of works better, except I don't exclude lines. Go back to using the grep only because I don't see a escape that. Escape that. Yeah, whatever was doing the let's just do this. Let's do the Mac is going to be position 3. That's going to be position 1. The delimiter is going to have to be space and ether. Do 1. What is the ASCII for tab? Alt 09? Invalid delimiters. All right, we're going to not do that anymore. Cool. Anyway, it's fine. It's fine. So our output of our adapter needs to be addressed first. New step below. We'll call this clean Mac adapter name. Because why not? Yeah, we're going to what is it? Eval. Thanks. So let's see if we have, so is there any other better evaluation? Table.size. Where are we going to get? Okay, so I think this is similar to what we want. Because IP addresses is a single thing, but that's okay. IP addresses. Yeah, okay. It's just exporting each one of the IP addresses as a command. All right. And it's extracting it from an interfaces table. Interfaces, which has a name value. So let's see. We don't want interfaces, we want Mac. Field for Mac is, let's apply that here real quick. Adapter. Believe that, and then you could say something. I don't think we need to iterate. I hope that works. Let's see a big error. Come on, big error. Oh. Let's find. Here we go. This one's a better, much better example. Okay. Network, because it even uses the same thing. Network adapters. We don't want to use Mac. We want to use adapter. No, we don't even want to use that. Mac.adapter. Mac.adapter. Mac.split on this. Mac split string. Need any of this for stuff. Grab it and say return equals max string. We'll do adapter dot split. Let's see. Adapter dot split 0 dot to string. We'll call it let's see, adapter clean. Wonderful, beautiful, love it. Looks perfect. Let's go all the way down here. All right, let's see if, okay, we've got merge adapters with Macs. That's target table network adapters. So network adapter should have Macs in it now too, right? Yep, we got names, we got masks, good looking masks. We got MAC addresses and adapters. Phenomenal. Set IP addresses, update CNDV IP addresses. Let's test this, make sure that it gets updated correctly. If this all works, we're probably just going to save this, publish this, and rerun it. I'm probably actually going to, yeah, let's do it. Save it with libraries, publish. Let's triple check and make sure that this, okay, we've got this FreeBSD classifier. We're going to change the pattern to the FreeBSD server instead. I'm still going to call Linux installed software because I think that still works. Maybe we copy it later. Let's go into the Linux servers. Again, let's get rid of freenas.local because it shouldn't be a Linux server. Just completely wipe it out. And let's go back to discovery. We'll do a quick discovery on our TrueNAS server. Classified as BSD server. Let's hope it stays there with the pattern. Hopefully there's nothing else in the pattern that's setting the class incorrectly. Not great. The output is ready. Why is it not running it? Okay, there we go. Ooh, it failed. We messed something up. CMDB FC initiator is not a known CI type. Has something to do with that, what we copied. So oh, I know why. Let's see. Let's go to CI class manager. So in the CI class manager, if we go to the Linux class, there's probably suggested relationships having to do with oh, okay. Nope, never mind. I found a support article. Let me show this to you guys. The support article tells us check the related CI type unrelated links for the record and essay pattern. So we're going to go to the essay patterns section. We're going to find BSD. We're going to open that. And we're going to open up the Linux one as well. And the no, that's not where it is. Let's see. Essay pattern. Oh, it's open pattern designer. All right, essay pattern list. Now we're going to find Linux. Related CI types. See all those? Now check this out. FreeBSD. Oh, vey. FreeBSD server. Look, no related CI types. So How do I get them to move over? Oh, not having to touch each one of them. Don't have an answer to that. So we'll just grab these in a screenshot real quick and just kind of hammer through them. Or we'll stop at NAS file system. Oh, I can't change them here after I opened all those. All right, never mind. Okay. New. Can I get a display name? I guess not. My goodness. Let's see. We're just going to write a script for this because I think it's easier. So we're going to take this table, SACI pattern, and add this query for Linux servers. And then while pattern m2m.next, just make sure we got the right stuff first. Build this pattern. Let's validate that this runs. We got 26. Is that right? Is that right? I don't know. 26. That matches. We got all those things, and it's attached to that particular pattern. So now we're going to, oh, yuck. Well, let me go back. Good thing that's good thing these things are logged in the log, because I can't go back. All right, so let's see. Now we're gonna just insert a new one. Let's see. I don't think we have to create a new glide record. I think we just use the old one. So pattern m2m dot pattern equals FreeBSD server. Is this? Then we can do pattern.m2m.insert instead of update. YOLO. Did we bring down the dev instance? That's a good question. We don't know. Oh, great. Created today. Let's. Let's create a new glide record. Okay, that works. Let's see. Let's see. Oh, I didn't even actually put CI type in there. Yeah, that worked much better. Perfect. Love it. Love it. Is it the same as Linux? Let's scroll about it. Ooh. Sort by the same thing. All right, fantastic. Let's go back and rerun discovery schedule again. Close all this nonsense. I don't think I synced the patterns. All right. Well, there's one more thing we can check. I think because I didn't do the discovery pattern sync. Let's go back into the FreeBSD server. Check the pattern. Actually, I think I know what the problem is. Let's just based on what I'm seeing there. in the identity, in the network section. Yeah. Got the wrong table. Let's see. This should be CMDB CI BSD server. BSD CI, and then boom, right there. Resulting table. Interesting. Okay, so anything else related to that? Save that with the libraries. Now we're gonna look up for anything with CMDB CI server. Yeah, okay. So yeah, we gotta correct all these. All right, and we're gonna do CMDB CI minus the $sign here. All right, and good. Great. Rename to FreeBSD CI. FreeBSD CI, BSD server, BSD server. Leave that like that. Rename this to, again, BSD server. We can't change all of these shared libraries. This is probably what I should have done to begin with. Okay, just get rid of all these. We've got the basic identification. So here's DNS. DNS doesn't care what CI you're attaching it to. Great. All right, FreeBSD identity. This is all FreeBSD stuff. This is inside the thing. Set DNS name for BSD server. That's outside of the DNS. Get DNS. Okay, fantastic. Linux distribution. We got to remove that. Update, start date. We get the start date from one of those things, so we got to remove that as well. All right, well, we kind of pared this down a bit. What can I say? Let's publish this. Let's go into our discovery servers, sync the patterns, and let's try it again. Third time's a charm. Failed exploring. Let's find out why I was failed exploring. Same reason. Missing. Still missing minimum set of attributes in network stuff. So let's find out why this is happening. Also, check the CI class manager, make sure there's not some weird requirement on networks for BSD servers. Requires a MAC address and a name for the network adapters. For every single network adapter requires a MAC address and a name. Discovery router interfaces. IP address has an IP address, net mask, IP version. Does not have a MAC address. Ooh, say what? That doesn't look right. So it doesn't have an IP address. Yeah, this is all sorts of wrong. Network adapters is not empty. Let's look at this. Network adapters. They all look relatively okay. The name, an IP, and a mask. Hmm. The MACs are coming across okay. The IPs are, this is not a real IP. I don't know why IGB0 is at the end of it. Adapters. So where is that getting set? Where's that IP getting set? Is it here? Is it still? It's before here. VNet 0. Yeah, it excluded that. Okay, so oh, it says it right here. This okay, interesting. From the adapter sheet. This is probably where it's all been messed up. Hmm. Let's do this. Let's say it says go to this URL. Well, let's go to the URL. Do what it says. Do what it says, Fro. Do what it says. All right. Retrieve payload button in the payload processing. tell us what it's missing. Hang on a second. Missing matching attributes. In payload, missing minimum set of input values for criteria matching attributes from identify rule, discovery, router, interface. Oh, okay. This might be a really easy solution. Name and IP. What does it need? Name and MAC address. Where's the MAC address going? NVCI network adapter MAC address. Network adapter MAC address is not there. Okay, so this valuation is not. Oh, it's the one that we stole from. It's hilarious. Okay, so in the network adapter's MAC address, MAC, it's separated by colons. There's nothing wrong with it. Split on X. We don't need to split on X, and then take one, which is an empty string. We don't need to do any of this. That was for the Linux. That's easy. Save. It's so easy. It took me 20 minutes to figure out. Publish. All right, let's recalculate and see if those router interfaces now have MAC addresses, and the network adapter should have MAC addresses too. There's the MAC. Phenomenal. Let's find the router interface. That also has a MAC. Love it. Love it. Mid servers. For good measure, pattern sync. Let's do it again. This is good. I think it's taking longer than it used to before. So processed. Failed. Less problems. Let's go solve this one. Okay, so the other one is this one here, IP address. Let's see. VNet2 IP address. Yeah, VNet2 was empty from the beginning. ifconfig VNet2. Interface's name plus adapter's IP plus adapter's net mask. So there's something in here. IGB 01, loopback 0, PF log, bridge, VNet 0, and VNet 2. So there's 3, 6, there's 7 there. But there's only... Interesting. So that's super interesting. Let's turn our PowerShell back on and let's take a look at ifconfig VNet 2. That comes back with something, right? Let's see. Oh, let's see here. I think we have another code problem. So ifconfig for one interface in FreeBSD. I think I need a switch. Oh, I see what's happening. It is giving me just this. I having trouble reading it. So it's just giving me the VNet 2. Okay. So VNet 2 is here. What's not here? So IGB 0, IGB 1. I need 7 of these. LO 0. Oh, the bridge. PF log and bridge do not exist. Do I need to exclude them? Make them be excluded exclusively? Exclude PF. Let's see. PF log a bridge. The original question here is the netstat IN. All right, so let's take this down. Grep the column table name, pipe that into awk print 1. Filter unique values. So netstat of not netstat if config of bridge. Hmm. This is a FreeBSD bridge. Why bridge and PF log? So pf log netstat hide. Well, we could do this the super easy way for now, just to get it to work. New step below. Yeah, we're going to parse a variable. Let's see. Interfaces source, the target is interfaces, and the target field is name, the value is eval. I think that's right. I was close. It needs to be in the inside. Oh, it just leaves empty stuff. I don't want that at all. Okay, first table, we're just going to do interfaces. Second table is also interfaces. Table, filter table, source table, target table. Meet any of the following conditions. Does not Let's see, just not equal. It's not equal. So interfaces name. Bridge and PF log. Let's test that. All right, I think that's this problem here. Try that again. Yeah, it's better. Okay. So yeah, let's see. Unique. Save with libraries, publish. Oh no, stop. I did not include the lines correctly. So now I want to include the lines. Include INET lines. There we go. That's actually what I want. Not quite right. Interfaces name. IGB 0, IGB 1, low 0, VNet 0, VNet 2. Oh, and then there's 6 instead of 5. So let's look at this again. What has 2 things? Actually, it's 3. This is 3 INET 6, INET 6, INET. It says none. That makes sense. It's definitely expecting to see a like for each one, and it's just, and it tries to plug all of the requests into the same thing. And like IGB1 doesn't have an IP address. None of these do. LO0 and IGB0 have 3 addresses each. It was not planning to have how do we do this? This is very interesting. They're all active. Huh. Hey, what's up, Haiku? We're looking at some netstat to try to figure out how to isolate just certain interfaces to pull. And it's on FreeBSD. I'm trying to copy from a Linux variant, but and a HPUX variant. It's just not working great. Let's see if we can get some inspiration. Let's try AIX. Let's see what we can get from there. We need let's see, AIX server. Here we go. Oh man. Sounds like fun. Maybe. Let's see. Can we do ifconfig au? Correct. Inet. We can do that. It just doesn't tell us. Data table gateway contains link. Hmm. I have config AU. What's A do? So the information about all the information is in the system. What does use do? Well, only the interfaces that are up. Let's add formatting to this. So if we do AU grep, AU, but let's also do F and do oops, do I have I don't have insert on. It's just inserting. All right, let's do this. I have config AUF, and then let's put in some. Look at the man page while we do this. Let's put in see examples for more options. Okay, come on, come on, come on, come on. Oh, it's the formatting of things. It's not the actual columns. I do a D. Okay. Hmm. Oh, can we do LINET? INET 6. Yeah, let's do that. Let's do INET 6. Let's just do INET. We're gonna save this with libraries, publish it, and then we're gonna refresh the page because I got stupid artifacts. All right, let's instead do ifconfig-l inet debug mode connect. All right, and I guess that doesn't work. That. I'll figure out now how to take this command right here. Get it on 2 lines. I guess I could have a default line separator of space. Oh, beautiful. I think that fixed my problem. It did fix my problem. We could probably just leave that in there for now. And we just do INET. At INET 6. We don't need IPv6 yet. Where's the IPs to create the adapters? I have to get the MAC addresses. The problem with the MAC addresses is going to match up with the interface names. Just merge adapters with the MACs. Network adapters. Now just be 2. Actually, it should only be 1. There's 0. Look at that. What the world? What the what? Oh, I gotta go here. Yep, there's just 1. Interface 0. Wow, that was painful. All right. I hope this works. It shouldn't negatively affect my router interface either. So yeah, let's refresh mid servers for good measure. And we'll come back. Hey, look at that. We have created a CI in the BSD class. phenomenal. And it's got KVM, FreeNAS, local. We don't have. All right, hang on. We gotta add some related lists that are not there yet that would look better. Network adapters, storage HBAs, storage devices. Network adapters, storage devices. Let's look at this related list. So we'll just copy from it. Network adapters, storage HBA. Let's see, storage HBA, computer, storage device, computer, file system, computer, subscribed by. Oh, wait, no, we don't want that. File system, computer, software installed. In process, computer. Want the relationships here. TCP connection, computer. Attachments, CIIPs. DNS names for CIs, memory module. I have the right software installed. Yep, I do. Okay. I just don't have any software. That's fine. I gotta fix that next time. But let's look at the network adapters. So instead of having all that not a number nonsense, we have IGB0, the MAC address, we have an IP address, we have a net mask. We don't have a manufacturer, and we have an IP address. Fantastic. A lot of work, but we cleaned up some of our discovery patterns. We kind of went over what we did last time. So now the next step, next time we come back, we'll probably take a look at maybe filling out some of the software installed, get some of those running processes classified, find out how to get through Beehive. We've already got some of the key functions figured out, the key commands in order to get information about the running VMs. So as soon as we get those running VMs, then we can start applying them and connecting them to actual other CIs in the system, showing the virtualization layer. Thanks everybody today for hanging out. Anybody have any preference where you'd like to go next? I'll rate out the remainder of you guys. I can either send you to a friend of mine who's playing The Legend of Zelda. If you guys want to watch some games, I can send you to some other coding. You got some Advent of Code streamers going on. If we want to try to go to there, your guys' call. Let's see this guy named Stu Squared. He's doing Advent of Code. Let me grab his information here.